Hello guys and welcome back to my channel. We are now at lecture number 2 for dipole moment. So let's continue the discussion of dipole moment and let's see what are the varieties of questions that can be asked from this topic of dipole moment. So I've already uploaded one video on dipole moment which covers the basic concepts, what dipole moment is, and how there are some rules of finding dipole moments. I've already covered that video and I'll be putting that video in the I button above. You can just click on that and go through that video. So this video is a continuation of the same. So let's continue and do some other topics on this. So let's start. See, in the last session, I have told you what dipole moment is, and I told you a few things about how to draw dipole vector diagrams, right? So let me just revise that one. I told you that if you have a lone pair, you have to draw a long dipole, a long arrow. If you have a, bond for lone pair, long dipole, and always away from the central atom, right? And for bond pairs, right, what you have to do is for bond pairs, we'll draw a short dipole. Dipole will be but a little short dipole, and this dipole will be directed towards more electronegative atom. So these are the things we discussed in the last class. Today it's going to be majorly about different types of problems. So let's start with the first type of problem. Okay, problem of first type, which is basically on the basis of diagram. So type 1 questions, which can be asked in J or NEET exams, or even your school exams if you are preparing for school exam. So type 1 question, geometry based. Okay, so first our question that will be asked on this topic is geometry based. So let's do this question. Question, why BCl3, or let's say CCl4, or they can also ask like why PCl5, why SF6, all of these are non-polar. Okay, so when you get a question of this type, you can do it using the concept that I'm going to discuss today. So let's start. Let's see this. See, if you really want to do, what you have to do is you have to draw the diagram. You can visit one of my lectures where I've discussed how to find the geometry of a molecule. I'll put that also in the description of the video so that you can go and watch that video on how to find the hybridization of substances in less amount of time, or how to find the shape and everything. So BCl3 has, I'll be doing it for just for quick purpose, and I'll be telling how to do it. So boron has a valence electron 3 and chlorine is 7 to the 21, 24. So divided by 8, that will give me 24 zeros. So that means 3 bond pairs, no lone pairs. So since there is no lone pair, what will happen? The molecule can have zero dipole moment. Now let's draw the diagram. This is the diagram of BCl3. Now how to do this question? See, you have to draw the vector diagram for this. So let's draw the vector diagram. So vector diagram has a head and a tail. Now, as per the concept we know, the head of the arrow point towards more electronegative atom. Out of boron and chlorine, which is more electronegative? Exactly, chlorine is more electronegative. So there will be dipole going towards chlorine and having a positive charge at boron. Again, here also the same thing, and here also the same thing will happen. See? So there are 3 dipole moments, directed like this, and the angle that it has is 120 degrees. Right now, as per physics, we know that if there's a vector going up, and there's a vector which is, here and here, then this will have an angle of 60 degrees because it's bisected, right? Now, as per dipole moment, if there are 2 vectors going like this and this, we have to find the magnitude of this vector, resultant vector. So let's find the mu resultant between these 2 vectors, vector 1 and vector 2. So we know as per physics, mu resultant would be under root mu square, see, plus mu square plus 2 mu square cos 60, right? Cos 60 degrees. Now cos 60 degrees minus half. We all know that, right? So since we know that cos 60 is minus half, we can put it here and find the answer accordingly. So it will be mu square plus 2 mu cos theta. So this angle is 60 degree. Sorry, it's 120, my bad. Yeah. So the angle is 120. Between these 2 forces, what's the angle? Yes, exactly 120. Now 120 is cos minus, see, we know it will be cos 90 plus 30. So cos 90 plus 30 is basically second quadrant, and in second quadrant we have cos as negative, so it will be minus half, minus cos 30 degree. So it will be under root mu square plus mu square plus 2 mu square into minus half, right? Minus half. So minus minus get 2 gets cancelled and minus becomes minus. So we get mu as an answer. So what do you understand? The resultant is actually mu. So see, ultimately, what can I say? One mu is up and one mu is down. See, this is mu down, this is mu up. So total what will happen? Mu will become 0. Therefore, it is non-polar. This is the exact, elaborated or, I would say detailed way of solving this question. But of course, I have to already told you what is the shortcut. The shortcut is this molecule, see, is this molecule planar? See, yes. So see, is it actually bisymmetrical? See, yes, of course. You cut it from this side. You take the molecule and cut it from here. See, bilateral symmetrical. Same side here, same side here. It cuts into 2 equal half. So that's a shortcut of finding the dipole moment. Dipole moment is 0 because it has the symmetry present. Now the same thing you can do for CCl4 also. CCl4 has symmetrical structure. So since it has symmetrical structure, what will happen? Mu will be 0. Same goes with PCl5 also. See, one chlorine here, one chlorine here, one chlorine here, one up and one down. Is this symmetrical? Yes, of course. See, cut it from here. So you cut the molecule from here. What will happen? Up and down, symmetrical. So this has mu 0. You can draw a vector diagram also to prove the same. How? See, out of phosphorus chlorine, which is more electronegative, of course chlorine. So electron will go up. See, here, then up, then down. So see, there will resultant which will go like this. So these two will cancel, these two will cancel. So mu 0. So any molecule which has no lone pair and has a symmetrical geometry has 0 dipole moment. So it is non-polar. So all of that's why they are all non-polar, because the vector diagrams cancel each other. Okay, now we are at type 2 questions. So type 2 question will be lone pair based questions. Okay, questions with lone pair based questions. Okay, so let's do it. So one question, see, suppose they can ask you that out of NH3 and NF3, out of NH3 and NF3, which is more polar? Now see, why I'm not saying one is polar, one is non-polar, because if I told you in the last lecture, you can watch that, if a molecule has one lone pair, it is going to be definitely, if a molecule has one lone pair, it is definitely going to be polar. That's why I have assumed that they will be polar. But the question is, which is more polar? So let's do it. So this is the question, and how to approach this question. The first thing that we'll do is draw the diagrams. Very important. So using the shortcut, you will find that it has 3 bond pairs and 1 lone pair, NH3. Okay, and NF3 has again 3 bond pairs and see one lone pair. Same thing. Now let us draw the vector diagram for each of them. Cool. So let's do it. As per the rule, the lone pair, lone pair has a longer dipole and away from the central atom. See, and NH, which is more electronegative, H or N? Of course, H is H is less electronegative than nitrogen. So what will happen? Just parallel to that bond, there will be a small dipole going towards nitrogen. Here also see towards nitrogen. Here also towards nitrogen, right? So mu in total will not be 0 because here the vectors add up. So vectors are adding each other. So as a result, mu1 will be a non-zero value. Okay, let's do the same for the next diagram we have, shall we? So let's draw it. So since there is a lone pair, it will go up. See, it will go up away from the central atom like this, right? Now fluorine is more electronegative than nitrogen. What will happen? Electron will go here, but a small dipole, of course. See, so these 3 dipoles are pulling this dipole down, but they won't be able to pull it completely down because these 3 mu's are very tiny as compared to the mu of the dipole moment, because it has lots of charge, right? Electron density is much higher, so mu is quite high. So in this case, mu will not be 0, of course. It won't be 0, but here the vectors cancels each other. As the vectors cancels each other, what will happen? The mu will be less. This will be less. This will be more. Therefore, what can we say here? Therefore, I can say that NF3 is less polar than NH3. Why? Because vectors are cancelling each other. This is the type 2 question that can come from this topic. Moving on to the next type, type 3. So I hope you understood this thing. If you feel that you have any doubt, you can put that in the comment. I'll be looking at that and I'll be immediately clearing it out. Okay, moving on to the type 3 question. Type 3 question. Type 3 question is when we have benzene based questions. Substituted benzene based questions. Okay, substituted benzene based questions can also be asked. Okay, so how to do those questions? See, like for example, question, compare dipole moment of the following. Okay, they can ask you this, compare dipole moments of the following. So first question is this benzene, one chlorine up, one chlorine down. Another benzene, one chlorine up, one chlorine here. Another benzene, one chlorine up and one chlorine down. Suppose they ask this question, they ask you to compare dipole moment. This kind of question also very common. So how to do it? So just remember, there's one shortcut that I always recommend that you use. Mu is proportional to 1 by theta. But theta is the angle between the two dipoles. So here this theta is 60 degree. Here the theta is 180. Here the theta is 120. So more the theta. So this is para, this is ortho, this is meta. Therefore, what is the answer? Answer is going to be more the angle, less the dipole moment. So what is the answer? Para is least, then we have meta, and the highest is ortho. This is the shortcut, but what is the lengthier method, the actual way of doing it? So we'll have to draw the diagrams. For para, the diagram of this will be towards chlorine, down towards chlorine. So both cancel mu 0. See, that's what para. Now about meta, one up and one down. This is the angle is 120, right? See, 120. Now if I take component of this one, it will be mu cos 120, mu cos 120, cos 60. So cos it, that means it will be mu up and there will be a mu down also. Root 3 by 2 mu down. Basically it will be less than mu. So mu will be less than 1. And then we have, see, after that what will happen? We have another one, ortho. So here, see, this is up. This will be exactly more. See, that much more. Mu plus mu cos theta, right? So it will be mu plus mu 30. Root 3 by 2. So this will be the answer. This is exactly the highest because the component of this will be mu plus mu cos theta. So it will be high. The magnitude will be high. That's why this is the logic of doing this question. So I hope you got it. Let's go to the next part. This is type 3. Take screenshot. Let's go to the next part. Type 4 could be, type 4 questions, could be about di substituted molecules with sp3 hybridization. Like for example, suppose there's a question like this, another variety. They can ask, like for example, this is a compound. And I've been asked, is it polar? Is this polar? So since this is sp3 hybridized, it changes the game altogether. It's a very beautiful question, typically asked in JEE Advanced. It was asked once in JEE Advanced. So let's do it. So how to do this question? To do this question, we'll have to consider the diagram. See, if you have OH, you can draw one time OH like this. See, right? I can draw it like this. And the other time I can draw it like this, right? Both are possibility. Why? Because is it sp3 hybridized? It has 3-dimensional structure. So I may have lone pair here, like there are many possibilities, right? So I can have both the possibilities for this molecule. So considering that, let's see how the diagram will go like. So this is structure number 1, structure number 2. Now for structure 1, what can I say? So for structure 1, I can say that this H is more electronegative or less. So it is less electronegative. So electron will come towards this. For which I'm drawing this? For this bond, I'm drawing the vector diagram. For this one, I will draw it like this. See, again, another bond like this. So I can shift it parallelly. As we know, right? We can shift two dipoles parallelly. So let me move it a bit up here, see, and here. I can move it, right? I can just shift it, simple. So they are canceling each other. So for diagram number 1, mu is 0, right? Look at the diagram number 2. H is more electronegative or high oxygen. Oxygen is more electronegative, so electron will come here. In this case, it will come here. Shift it together. I can shift it here. So if I do that, both the dipoles are coming towards each other. So they will not cancel. So mu will not be 0. So as per structure 1, it is non-polar, right? As per structure 2, it is polar. So what will I say? Therefore, mu net will be the average. Very good. It will be the average value. So 0 plus something by 0 by 2 is something, right? So it won't be 0 for sure. Therefore, it is polar. So these are the variety of questions that you may get from this topic. Either it will be a dipole moment based question, right? I've already discussed one type in the previous lecture, for which I have already uploaded the I button on at this corner. You can see that it will be there in this top of the video. Then I've discussed the 4 types of questions you can be asked. One is on the basis of geometry, other on the basis of lone pair, on the other on the basis of substituted benzene, and other on the basis of disubstituted having sp3 hybridized carbon. So these are the variety of questions you can get from dipole moment. So I hope you understood all the types of questions. Now you can go ahead and do any question on dipole moment. It will not be a problem. So with this, we'll stop for now. And next, I'll be coming shortly with another lecture that helps to solve questions in less amount of time. So with this, we'll wind up the video. So if you're liking this video, please subscribe to my channel and share it to your friends. Thank you so much.